Okay, so we're going to look at a parabola that has this equation, and what we want to try to do is get it into this form so that we can see where the vertex is and graph it. All right, this is just like when you maybe have a line and you want to graph it and you get it into the form y equals mxb so you can quickly see the y-intercept and the slope. So and for a circle, you want to get it into the form where you can find the center and the radius. So this is the form that we need to get it into, and we're going to do that by completing the square for x. All right, so we've already got y by itself, and that's fine, but we've got this instead of what we want, which is a square binomial involving x and some number. So to get that, that's when we're going to do the completing the square part of this. So I'm going to leave a blank after that 4x because I want to add something so that I'll have a perfect square binomial here. And then the 2 is still there. And now I'm going to figure out what do I add here to make this a perfect square binomial. And that's always going to be half the x coefficient squared. So half of 4 is 2. Square it, that's 4. So I'm going to add 4. Now I can't just add 4 to this equation. I mean, that's not acceptable. So I can either add 4 to both sides of the equation, which would mess up the left because I want to keep the left just y, or I can add 4 here and then subtract it again over here. So I really didn't do anything. If I add 4 and subtract 4, that's just adding 0, and that doesn't change the equation. And obviously you don't want to cancel those out because that's not the point. We're trying to get a square binomial here. And that's what this is right now. So y equals, I can now rewrite these 3 terms as a perfect square. That's x plus or x minus 2 squared, right? Because half of this is 2. If you multiply this out, x minus 2 quantity squared, you're going to get x squared minus 4x plus 4. So I just rewrote this as a perfect square binomial, and that's my x minus h quantity squared. My plus k is over here. This 2 and the negative 4. Add those up and I get negative 2. So now I have the equation in the form that I wanted it to be. It's in this form. Y equals x minus h quantity squared plus k. All right. Now look at the signs. The minus is okay, it is minus, and so the vertex here is going to be 2 because the minus sign is in the standard form, so that stays the way it is. And then the k is this number with its sign intact because it's plus k, so negative 2. So 2, negative 2 is the vertex of this parabola. And then I can just fill in some other points if I want to. I can put 3 in there. A 3 minus 2 is going to be 1 squared. Minus 2 is negative 1, so 3 negative 1 is on it, and I know that it's symmetric. It's going to be symmetric about this line x equals h. So it's symmetric about the vertical line that goes through the vertex, which is x equals, in this case, 2. So x equals 2. X equals h. All right, so, and you can fill in more points, but it's looking like that. Okay, let's do another one. So symmetric about the line, x equals h. That's always going to be the case. It will be symmetric about the vertical line that goes through the vertex, which is x equals h. Okay? All right, now we've got, this one has all these negative signs, and that's going to be a problem. So instead of trying to fool around with those negative signs, what we're going to do is move them out of the way for the moment. Now in the book they do this a little bit differently, and I think that it's confusing, so I would encourage you to do it the way I'm about to do it right now. So what I'm going to do is just multiply the whole thing by -1 so that I have the negative over here with the y, because I don't mess around with the y. I don't really do anything with the y. So if I have that negative over there, it's out of the way for the moment and I don't have to deal with it. And so I'm multiplying the whole thing through by -1, so I'm just going to change the sign on everything. X squared plus 6x plus 8. All right, and now I'm going to do the same thing I did before. I'm going to take the x terms and I'm going to complete that square so that I have a perfect square binomial. So x squared plus 6x plus something plus 8, and then whatever I add here, I'm going to subtract over here. So half of 6 is 3, square it, that's 9. That's the number we need. We're going to add 9 and subtract 9. Now, these three terms make a perfect square binomial, x plus 3 squared, right? Because if you multiply this out, it's x squared plus 6x plus 9. That's what this is. So I'm just rewriting it. And then over here I've got plus 8 minus 9, which is just minus 1. Now this is not equal to y, this is equal to negative y, because I multiplied everything by -1 when I started out. So what I have to do here now is I'm going to have to multiply back again through by -1. So now this becomes positive y, and I put the negative here. I don't distribute it because this is squared. You can't distribute it when there's a square here. So that just goes out in front, and then this becomes plus 1 instead of minus 1. All right, so now you have this parabola where you can still figure out what the vertex is. It's still going to be HK, and remember the H is going to be the opposite of this because this is a minus in the standard form. So H is -3. Whenever that's positive, it's negative, and when it's negative, it's positive. So it's -3, 1 is the vertex. And what this negative sign tells me in front of the square term is that the parabola is going to open downward. So the vertex is -3, 1, 1, 2, 3, 1. And now the parabola opens down. All right, so if I put in, say, -2, I'll get -2 plus 3 is 1 squared, but it's negative. So -1 plus 1 is 0, so -2 is 0. And again, the graph is going to be symmetric about x equals -3. So this line that goes right through the vertex is the line of symmetry. So whatever's on the right side is also going to be on the left side. So this opens downward, and you can put a few more points on there to make it neater. But when you have a negative sign in front of this term, it tells you that the parabola opens downward.